Okay, that's a good response. Anyways, so 5G is the fifth generation mobile wireless standard after 1G, 2G, 3G, and 4G networks. So there's a lot of hype around this topic. So because of the features that the 5G network providers are promising us, I mean, there's really high data transfer speed. I mean, imagine downloading a movie in under a second, and there's also better security and better accessibility. So before we comprehend the underlying technologies of 5G, let us understand how simple cellular networks work. Let's take an example of phone calls. So our goal here is to transmit audio from one mobile phone to the other mobile phone wirelessly. So as many of you know, it's done using electromagnetic waves. So you guys know what EM waves are, right? So analog signals from the voice, like whatever you speak, they're all taken in as analog signals, and they're going to the mic of your phone and then converted into digital signals. From there, there's a small module in your phone that converts those digital signals into EM waves from the transmitting device. From like it's a transmitting device in your phone. So are these signals to transfer to the in the same way as EM waves to the second mobile phone, and the whole process happens in reverse. So it's first converted into digital, and then it's again converted into analog, and that's the audio that we hear when the other person is speaking to you. So the problem with EM waves is that it has a lot of experiences a lot of attenuation. I mean, if you want to make calls with just EM waves without any additional features, you have to be probably in like close than like 10 to 20, 30 meters. That's all you can do. But we're able to make calls like across countries, right? So how is that possible? That's possible because of cellular technology. So let's see cellular technology. Cellular technology basically just divides the whole coverage area into hexagons. So each of these hexagons have their own tower. There's just one single cell tower for each hexagon. Now you may wonder why hexagons are used, right? I mean, it's simply because the areas won't overlap. Imagine using circles, right? If you're accumulating circles together, like something like this, there's always a bit of area overlap over there, and that's not efficient. So that's why you use hexagon. Yeah, obviously, it's not just hexagon. You can obviously easily use triangles also, or rectangles. That's also possible. But hexagon is preferred by the network providers. So this layout varies depending on the area, and it's also not necessary that the hexagons are of the same size. They could be they could be larger or smaller based on the area. Like in the dense cities and all, the area is a bit smaller, so you can cover like you need more signal towers over there. So and these cellular technology, as many of you know, we all think that it's wireless, but it's not completely wireless. Cellular technology is not completely wireless because each of these individual cell towers communicate to each other only through optical cables. So they're only receiving the signal from the mobile phones, and then they convert those data into digital data, and those data are converted transferred to optical cables. So now let's see how cellular technology actually helps in the communication. How does it help in the attenuation part of EM waves? So now EM waves from the mobile phone are received by the tower first, and then converted into optical signals, and then sent to the switching center. I'll come back to what the switching center is. So it's after the switching center, it goes to the next cell tower and then the mobile phone. So the switching center, uh, it's like the address book of mobile connections. So it knows which mobile is present at the current location. Like at this point, where is the mobile? Where is the connection going on? So it knows the cell tower area in which the destination mobile exists. So if I make a call from here to Hyderabad, the Hyderabad the location at which the Hyderabad phone is existing, that all the data of that it's there in the switching center. That's what handles all of this. So after going to the tower, the switching center, it routes to the nearest tower of the second mobile phone using the data that it already has, and then it transmits the data as EM waves, which can be interpreted by the mobile phone, as we already discussed. So this way, we overcome the problem of attenuation because it's digital. Like data has been transmitted to optical cables. There's not much of attenuation over there, so we don't have to worry about EM waves getting a lot of noise during transmission. So now the question might arise: you're not going to stay in the same place forever, right? You keep moving around. You go to some other cities, and how are you still able to pick up calls? How does the switching center know that your phone is right there at this point? So this is taken care of that whole there are it's because there's not only one mobile switching center, there are a lot all over the place, all over the range of coverage. So every time you move or you move to a new city or you move to some other country or someplace, what happens is the nearest tower, it picks up your mobile signal and then it updates the switching center with your location. So now if you're Initially, there's this one base switching center which knows your location. Like when you wherever you buy your SIM card, probably in a one area you buy your SIM card, that area switching center will keep hold of your initial base location. That's called your base location. Keep track of your the initial location. Then after that, wherever you start moving from the nearest tower and the nearest switching center, it will keep updating your info. They all are in contact. So that's how this whole cellular network works. And also another point over here is that for each area, the towers don't use the same frequency. They use different slots of between a frequency range, so that there's not much of a interference between the signals. So cellular technology uses something called frequency slot distribution. So this frequency slot distribution techniques like they make the data transfer more efficient. So in this example, suppose we have a bandwidth of 20 to 32 kilohertz, and there are three telephones sending data packets of bandwidth of 4 kilohertz. So these packets are sent through a modulator which shift their frequency as shown in the image. I think you can see the image, right? So these packets are sent through a modulator which shift their frequencies as shown in the image. And now if you look at them, they make use of the whole bandwidth, like the 20 to 32 kilohertz, they make use of it at the receiver side itself, the whole bandwidth. And band filters are used to retrieve the data at the receiver side. So this type of division is called frequency division multiple access. So although this seems like the perfect method to transmit data, it's quite inefficient. Can you guys guess why? And why is it inefficient? You guys can use the chat, or you can also unmute yourself. Am I going too fast, or guys?
No, it's fine.
Okay. So why do you guys think FTMA is? I'm saying that FTMA is inefficient. Why do you guys think it is? Okay, no answer. That's fine. Anyway, so what? Imagine if the second telephone doesn't send any data, and there's this 24 initially to 24 to 28 8 kilohertz range was used by that device, right? So that whole range will be unused. I mean, if you're transferring data continuously, it's fine, but if something breaks in between, that whole spectrum, like the 24 to 28 kilohertz, is becoming unused. So that's a waste of frequency over there. And other telephones can't connect to this line either. There are no methodologies to like select whichever the telephones are selecting, like giving out the signal, only they can use this frequency, right? So that's not possible. So that's why this method is a bit inefficient. So now that we understood how basic frequency distribution is done, so let's now see why do we need different generations of mobile networks. I mean, we had 1G, 2G, 3G, 5G, like 4G, and then we coming to 5G, right? So let's see why we have all those different generations. So 1G was the first commercial mobile network ever. So it was introduced in the 1980s. It used this FDME technique. Back then, it was the only that was the efficient technique for that time. So, but it's still quite inefficient as we already saw. So 1G used analog signals, which were more prone to interferences. Just like EM waves, I mean, they're very much prone to interference. The signal to noise ratio is very poor. And the audio quality also was not up to the mark. It was pretty poor. But then for the time, like for 1980s, it was good enough. So the data rate had a maximum of 14.4 kbps. So it was quite good for a start at that point. But as technology improved in subsequent years, these data rates couldn't accommodate all the features. So there were also no security features in this network. So that's also a minus over there. And also consumed a lot of power. I mean, that was the major reasons why the phones were like too big. I think you guys remember how the phones used to be back then. They were like too big, like almost this big probably. And they're also heavy because they needed a lot of power to even transmit those signals. The batteries were very huge. So I mentioned all the points in the slides. You can go to that. Anyways, so next comes 2G. So 2G was the first mobile network to use digital signals. So digital signals had a better signal to noise ratio than analog. So they also came with higher data transfer rate features. Since they were digital signals, it was also possible to encrypt them and provide a security feature, which was lacking in 1G. And these devices didn't also use a lot of power. They didn't need a lot of battery. That's when the phone started becoming smaller and smaller because they reduced the battery level. So this is also the first time when SMS and internet features were introduced in phone. I mean, that was the whole trend back then. When 2G came out, the first thing people started using was SMS. SMS services were really famous back then. So unlike the difference with 2G is like unlike in 1G, 2G use a different division technique. In 1G we use frequency division technique like the FDMA. Here we use TDMA and CDMA. TDMA stands for time division multiple access. CDMA stands for code division multiple access. So now let's see how these techniques differ from FDMA. So also guys, is it too boring? I mean, if you guys have any doubts or queries, please feel free to use the chat section. And this pace is all right, right? Am I going too fast? Okay. Okay. So TDMA. TDMA is a digital multiplexing technique for combining like several low rate digital channels into one high rate one. So time slots are grouped into frames, and a frame consists of one complete cycle of time slots with one slot dedicated to each input device. So in a system with maybe say n input lines, each frame will have n lines, and with each slot allocated to carrying data from a specific input line. So now this might seem like it's the same as FTMA. There's nothing different, but in reality, the method is pretty much more similar, like simple than FTMA. Because in case of FTMA, remember we used modulators and all, and we used frequency shifters and all were needed. Over here, that's not necessary at all. So and bandpass filters are also not necessary. So this is quite simple, and also this is because it's digital signals are used. So it solves inefficiency. And additionally, this one also solves the inefficiency when there was one device which was not sending data, right? That problem is solved in TDMA. So let's see how that is solved. So in TDMA, there are two types. You can say time division multiplexing techniques are two types: synchronous TDM and asynchronous TDM. So the synchronous one is like pretty much similar to FTMA. It is inefficient as just as FTMA, but it's just faster than FTMA because these use digital signals. But the thing in statistical TDM is that time division multiplexing is that your slots are dynamically allocated to improve bandwidth efficiency. So only when an input line has a slot's worth of data to send, only at that point that it's given a slot in the whole output frame itself. Otherwise, it's given to some other device. So whichever device is ready at that time. So this solves the inefficiency of when one, like in the FTMA case where I discussed that what if the second telephone doesn't send data? That frequency range is incomplete, right? It's going useless. It's useless. So at that point, that point FTMA doesn't do anything, but TDMA, statistical TDM, makes sure that it uses that frequency also. Like so, it allocates to some other device that's available at that time, which has data to transfer. So this way we overcome that inefficiency. And the next one is code division multiple access. So code division multiple access, it's like something that's entirely different from TDMA. So the basic concept in CDMA is that users wish to communicate through it or given a shared code. There's something like a security feature. So when multiple codes occupy the same channel, only those users having the same code can communicate with each other. It's like if I have code number 1 and my friend also has a code number 1, only we two can connect. Whatever audio data to transmit only gets received or sent from these two devices. So the data transferred with code number 2 cannot be received by code number 1. So that's how it is. So the CDMA, after data digitalization, expands out the data over the complete available bandwidth. It doesn't limit itself to like 20 to 24, 24 to 28, 30 to 32, something like that, like in we saw in FTMA or TDMA. So this one uses the whole bandwidth, wherever space is available, it uses it. Because we know, right, the signal is not going to get lost because it's not going to get confused because it's based on code. Only when the two codes are similar, then we are able to connect to two devices. So after it expands the data of the complete available bandwidth, the signal of the users is widespread in the complete bandwidth by special coding. So that's a whole different algorithm that is uses. I'm not going very deep into that. So at the end of the same special code, it's used to recover the signal and data. The system of CDMA, it needs a much precise time step on every piece of signal. You need to know at which point the signal is sent, from where it is sent. So only then you can gather data at the receivers, and it also like the perfect data in the same order that we sent it. So that's needed over here. And the signal, moreover, the signal is actually encoded after digitization for security features. It's a bit complex, but I hope the next slide will help you understand the difference between all the techniques we discussed so far. And you guys, if you guys have any questions, also please feel free to ask. So let's see. TDMA is like into like a method by which communication is carried out by speaking one at a time, hence time division. And FTMA can be looked at like as if communication is made by using different pitches, like different frequencies. That's why frequency division. And finally, CDMA is like people speaking simultaneously, but in different languages. So because only those who speak the same language can understand each other. So it is possible for multiple conversations to take place at the same time. I hope this analogy will help you understand. Guys, any questions so far?
No way.
Okay. Anybody else? Or can...
No way.
Good. So next, after 2G, we have 3G. So 3G was the next upgrade after 2G, and while 2G was good enough for calls and manageable for, it was okay for internet browsing and all. But 3G upgrades the data transfer of 2G. I mean, as the bandwidth used is much wider than before, more devices were able to be accommodated in this frequency range. So 3G made internet browsing much faster. HD, this is the first time we were able to even view HD videos on your phone. HD video streaming was possible. Although it had a lot of advantages, the range of the signals were lesser compared to 2G. I mean, this is obvious because higher the frequency of the wave, lower the wavelength. That's the inverse square law. Sorry. So since the range was pretty low, you had to add more cell towers in these hexagonal areas that I talked about. So new setup was introduced for 3G. That was a lot of investment for network providers. So next we have 4G. So after 3G, we have 4G, right? So 4G is what we all of us are using right now. So it had used a newer signal propagation technique. So something called, specifically it's called multiple input, multiple output, and also with together with orthogonal frequency division multiplexing. So 4G improved the data transfer rate. It's not possible to even watch live TV on your mobile phone. So that's a huge step, right? And this is also a huge step for IoT. I mean, all the devices were able to be connected for a long time, as in every instant they were still connected. Oh, 4G plus. Okay, then. So I was thinking about 4G plus. I did do a lot of research on that. 4G plus is more like the theoretical 4G that we're talking about right now. It is supposed to offer more speed than 4G plus. 4G plus was introduced more for the stability part of to bring it more stability. So it had slightly lesser speeds, but then that's what we're using. The LTE that we're using right now, what they did is they just improved the bandwidth. They added some more bandwidth to the frequency range, and then the speeds are a bit reduced, but it was more stable than the theoretical 4G that we are talking about. That's why every mobile phone that we're using right now, they're all using 4G LTE. So this was a huge step for IoT also. Okay. Oh yeah, so it changes the edge because the thing is all of these networks are all backward compatible. So it is possible that in some of the areas only 3G tower is available but not a 4G tower. So it shouldn't be like your cell phone should support only 4G, right? So it is able to convert use whichever frequency is available for that point of time. So it could use 3G or 2G, whichever is available. So that's why I mentioned that they're all backward compatible. So so 4G started using 2 to 8 gigahertz bandwidth. So that's a huge range, and more devices were able to accommodate in this range, and that's why IoT devices were also improved at this point. So let's see what I mentioned: multiple input, multiple output, right? So it's called MIMO. It does sound funny when I say MIMO, but okay. So until 3G, the signals were propagated in a way such that they always take the shortest path available. I mean, that's what makes sense, right? You want to transfer data and you want to use the shortest path available, so it's always fast enough. But this was a limitation that didn't let us transmit multiple signals in the shortest path simultaneously, because there could be interference. What if all the signals were passing the same path? And there would definitely be interference, right? So that's why MIMO and OFDM had a solution to overcome this limitation. So to describe MIMO in layman's term, it's simply transmission of multiple signals from each transmitter and also receiving multiple signals at the receiver. So simultaneously, there'll be a lot of signals transmitted. But this means that more than one antenna can be used to provide a device with sturdier connection. So you might be getting signals from two antennas from the same tower. I mean, two is always better than one, right? So that gives a bit of stability over there. So traditionally, radio engineers treated natural multipath propagation as an impairment because, as I said before, there could be interference when they're all passed the same path, right? But MIMO was the first radio technology that treats multipath propagation as a phenomenon to be exploited. So MIMO multiplies the capacity of the radio link by transmitting multiple signals over multiple co-located antennas. Sorry. Oh, so okay, I was saying something. This is accomplished without the need of additional power of bandwidth. So as you can see, with 4G, when 4G was introduced, there was not a lot of investment done by the network providers. I mean, some of you must have been knowing about that because the original 3G towers are also used for 4G. They just actually increased the bit of bandwidth. That's all they did, and they improved the method in which the signals are transmitted. So space time, there's something called space time codes. So it's something somewhat similar to CDMA, as I said. Some codes are used, right? So those are employed to ensure that the signals transmitted over different antennas are orthogonal to each other. So I mean, if I can go into like the theoretical stuff of it, but I'm not going into right now. It's based on matrices. So if you consider two orthogonal matrices, I mean, you guys must have been knowing, right? They're not like they're uncorrelated. So they're not going to interfere at any point. They're not related to each other at all. Like, in simple words. So it doesn't matter if you pass them in the same path; they don't interfere. They're called orthogonal signals. So that's what MIMO uses. So the signals are transmitted orthogonal to each other, so making it easier for the receiver also to distinguish from one another, each one another. So it's like two signals, signal one and two are going to the receiver, and they're all going to the same path. But since they're orthogonal, the receiver can figure out which is signal one and which is signal two. That's also based on the codes that are used at the input side. So even when there is even when there's line of sight access between two stations, like two towers, it's not necessary that they have to take the shortest path necessary shortest path right now. They can take multiple paths. So in that way, you can accommodate more signals in this same bandwidth range, and still there's no interference involved over there. So that's a win-win situation, right? So that's what happens in multiple input, multiple output. So next one, orthogonal frequency division multiplexing. It's unlike in 3G, like here 4G is using it, right? But it's a bit of a complex mathematical concept, so which I'm not going into right now. It's like involves algorithms that use something called fast Fourier transforms. In simple words, OFDM divides the data stream into numerous low level data streams, low data rate. I mean, and this works more or less in the same as TDMA. So all the signals produced after undergoing the OFDM process are orthogonal. So they're uncorrelated, as I said before. So they won't interfere with each other as well. Yes, Nitesh, it's pretty much DSP. I mean, it's in the name, right? Digital signal processing. Anyway, so this is why MIMO is like possible without major interference between signals. That's all about this one. So I know the title said that evolution of 5G. That's the workshop title, but I haven't spoken about 5G at all. So here it is. The next half session is fully dedicated to 5G. And feel free to ask any questions at all. Any questions so far, guys? Doesn't matter if it's a small dot. We're just going to discuss. I'm no expert in 5G either. Okay, no questions, I guess. Okay, cool. So 4G was great. I mean, it had high data speeds and it almost had all the features that you could think of. I mean, you were able to watch live TV. But why is 5G be introduced? I mean, doesn't 4G suffice all our needs? So what do you guys think? Why do you think there's a need for 5G? This is a question everybody could answer. Come on, guys, why do you think 5G is needed? Okay, more speed. Just that. More money for MNCs. Yeah, that makes sense too. So what else? There are a lot of first years over here too, right? What about you guys? Yes, better security, yes, definitely. Okay. Yeah, that's about pretty much about right. So let's see. The frequency spectrums that we use so far are getting more like crowded with devices. So as I said, in the 21st century, we started getting a lot of IoT devices, and they all are interconnected with all like at all times. I mean, they're not taking breaks in between and all. They're all pretty much connected at all times, and they use the frequency range also, right? The same 4G signal frequency spectrum. So when the billions of devices are connected like this, it gets a bit crowded. So obviously, you could see a bit of a delay, and there'll be a lot of latency issues, and your data rate transfer rate will be reduced drastically. So that means there's just not enough bandwidth for all the devices over here. So in other words, there's just too much data traffic. So devices must take turns in transferring data, which is not good. So this is exactly why we need 5G. Like as you can see in the image, the frequency above 6 gigahertz has not been commercially used. So in 4G, I said that they were using from 2 to 8 gigahertz, right? The 6 to 8 gigahertz is what wait, someone over here mentioned 4G plus, right? 4G LTE. So Ben, yeah. So the 6 to 8 gigahertz that was extended for 4G LTE. So it was not used as much. So, anyway, so starting from 6 gigahertz to 300 gigahertz, that's where we are improving. Like that's the additional frequency spectrum that we're going to use now. So far, it has been just a few kilohertz or maximum 1 megahertz. Like that's what we're increasing for like 2G, 3G, 4G. But for 5G, this is a massive upgrade. See, 6 gigahertz to 300 gigahertz. That's a lot of frequency over there. So commercially, 5G is going to make use of this empty spectrum. So it pays for even higher data transfer rates, and a lot of industries will be benefited. So you can some just to name few, it's like this remote surgery, the smarter IoT devices, and obviously Swastik mentioned better security also. So that's a lot we can do with 5G. Anyways, so there are five important technologies for the methods that are used. So the first one is millimeter waves, then there's small cell, there's massive MIMO, and there's beamforming and full duplex. So you guys have any ideas what any of this mean? Any idea at all? You guys can guess me what millimeter waves are though. Any guesses? Yeah, exactly. Okay, so let's see first what millimeter waves are. So as I mentioned before, 5G uses higher frequency spectrum, right? So the signals produced in this millimeter, like in this range, are called millimeter waves. If you find the wavelength for this frequency, it will going to be in millimeters. So according to inverse square law, it is obvious that there's going to be a lot of signal loss. So as I mentioned before, even for when you're converting from 2G to 3G, we had to install new towers, right? That was because of this attenuation, because of the range of the signal transfer. We had to introduce more tower cells. So this millimeter waves, they are of extremely high frequency, 30 to 300 gigahertz, and they're all short range and high attenuation. So millimeter waves are like not strong enough to travel long distances, not to penetrate through walls. So these signals are sometimes absorbed by atmospheric gases also. And if the towers are like really tall enough and the data transfer to like in higher altitudes, they're definitely going to get absorbed by these atmospheric gases. So it's really unreliable for long distance communications. And the range is also quite poor when compared to 3G and 4G. So 4G's range, like a single 4G tower, its range was about 15 kilometers. But 5G towers have a lower range of about only 500 meters. Okay, you see, right? The data transfer rate has increased drastically, but at the same time, the range, like signal range, has reduced so much. So you can understand how this is a major problem when it's combined with attenuation also. So the solution with this problem is called the solution we produce, the technologies produce are small cell networks. Let's see. So small cell 4G used large high power cells to transmit signals, but if we use the same technique for 5G, it won't work because of the problems that I mentioned in the previous slide, like the attenuation and the not able to penetrate to obstacles and all. So to work around this problem is to use multiple smaller base stations to transfer signals. So you guys have any idea what smaller base stations is? I mean, the image is pretty much explanatory, right? So, you guys have anything to add over here? What do you guys think about the small cells? Okay, sorry. So the workaround for this problem is called small cells. So they form sort of a relay connection. So you can understand better from the second image. You can see initially in the first image you can see that the signal is getting cut off by all those trees, right? And then the signal is not going to the mobile phones. They're not able to pass to that. So that's why if you use smaller cells, small towers over there, like in close proximity, so even if you go behind an obstacle, the other cell tower will get the connection and will transfer it to you. So whatever small cell tower is next to you, whatever is closer to you, that will be providing you the signal. So this the method will help devices have still access behind all the obstacles, and especially in cities when like all the buildings are together, and there's a lot of interference possible over there. So that's when these small cells help. Okay, so next we have I mentioned something called massive MIMO. So just like in 4G and 5G, 4G, 5G uses make use of MIMO too, but it is in a much larger scale. So in 4G, what happened was it was the same thing. I told you that 4G used MIMO, and each tower was able to send multiple signals simultaneously. So each tower had like what to say, some 12 to 16 antennas. That was what 4G's limit was. But 5G made it into 100 antennas. So 4G could have done the same thing too, but then it didn't have the small set technology back then. They didn't implement it back then. So the from this one, but there is a problem of interference over there. I mean, back then it was 16 signals simultaneously. Okay, it was manageable orthogonal signals. But now imagine 100 signals from the same tower sending in direction, like sending signals in all directions. So that's really a problem over there. There's going to be a lot of interference. So this is where beamforming comes in. Beamforming. So beamforming is kind of like a traffic signal system for cellular signals. So instead of broadcasting the signal in all directions, these base stations can create directed beams of signals. So boosting strength wherever it's needed and cancelling out the signal wherever it's not. Like imagine if there are two people using the 5G technology on your phone, and one of them is watching a video and one of them is just put the data on and is just waiting for WhatsApp messages or something. So which one do you think needs a lot of bandwidth or a lot of internet over there? And obviously is the one watching the videos, right? So towards him, whichever small cell is closer to him, towards him only it will be providing more data over there, so that there will be focused to that device more than the other device that's just waiting for WhatsApp messages. So it focuses on signals in the direction of the device. So its precision makes it way more efficient and also causes less interference. The targeted, like before, as I already mentioned, that it's not necessary that the signal should take the small, like the fastest path, like the what to say, the shortest path available, so that it can reach the devices. Since the signals are already pretty fast, and since you're also accommodating more signals simultaneously, it's not possible to put them all in the same path. So what these algorithms, what this algorithm do is they bounce it off from other sides, the other directions, so that more signals can be accommodated. That's all right. Okay, sorry, I just need to take a water break. I'll be back in a yep. Yeah, sorry about that. Anyways, so these signals, as I said, they need not travel in the shortest path available. So they can go from, let's say, from A, if there are 2 points A, B, C, and A to C is the shortest path, it need not take A to C. It can go to A to B and then B to C. So something like that. That way more signals are accommodated. So all this is handled by the signal processing algorithms. So that's where the DSP part comes in. Nitesh, as you mentioned, it's all DSP. Yes. So next we have full duplex communication. So full duplex communication is all. Oh, Nitesh, I have a question. It won't take more time. Yeah, it will take more time, but then because of the small cell technologies over there, it's like it's not going. All the small cells are like what to say? They're placed like between a range of 500 meters, maximum of 1 kilometer. So you just have to send the data to one small cell. That's all you need to do, and after that, the data is going to transfer pretty fast. All this calculation part is done in the higher tower, the bigger tower that we saw like initially. That's where all this calculation is done. The small cells transmission is like pretty fast. Then when there are too many cell towers next to you, it's obviously almost going to take the shortest path only, like just a slight deviation. And signals transfer fast enough so you won't even notice the difference. So here we have full duplex communication. So it's all about increasing efficiency and speed. So picture a walkie-talkie. Only one person could speak at a time, right? So that's called half duplex communication. So either input data or output data, like, sending data or receiving data. Only one of it can happen at a time. So this is called half duplex communication. Meaning, now think in terms of data. I mean, 4G, while allowing you to send data and receive data at the same time, actually uses two channels. So so that there's no interference. I mean, two channels were used. One just to send data to other devices, and one just to receive data from. In this way, you had to split the whole frequency spectrum half like into two halves. One for just for transmitting and one just for receiving. That's inefficient, right? So in some other networks, the same thing, full duplex was achieved by taking turns in the whole frequency range, like just like a walkie-talkie. So that was possible. But the new technology used in 5G allows both sending and receiving data to occur on the same channel, and this doubles the capacity and results in a massive efficiency gain. So you can see, right, the same for 6 to 30 gigahertz, everything like the whole frequency spectrum is used for sending as well as receiving data simultaneously. So let's assume that it's a 1 gigahertz channel over there, and let's assume the trains or the data transmitted and data received. So 5G uses something. There are this fast silicon transistor switches. The silicon transistor switches that for an instant just switches the whole process, so that you can see in this train how they're going around each other. So you can imagine in digital signals type. It's really hard to explain how I can do it, but I'm just saying that there's a small switch, the really high speed switch that will momentarily reroute the whole signal so that they can travel past each other. So this is how 5G uses the frequency efficiently. So all the 6 gigahertz, the 30 gigahertz, 300 gigahertz frequency is not going to go for a waste. Everything is used. So now let's see a few advantages like for applications of 5G. I mean, why do we need 5G at all, right? So uh, okay. Oh, okay, Ben, you have this question, right? Yeah, I was about to come to that in the midst. Okay, anyway, so the thing is, the network providers do not have 5G as of now in India. Just recently, that Airtel is going to have their starting their trials right now. But there are people who are branding 5G as a feature in India. When think about it, most of the phones that people have right now not even supporting 5G. How do you think they can, brand that right now? They're just changing 4G LTE into 5G just in text. That's just as good as using inspect element and changing your grades. That's all it is. Anyways, this happened in the US also. Then there was a huge lawsuit for that, and then finally they had to remove it. So now let's see in healthcare. There's something called remote procedures. So have you guys heard about Ericsson? You guys must have heard about, right? Sony Ericsson or something. Swedish. It's a Swedish telecommunication industry. So they have been collaborating with King's College London to see how 5G can be applied in surgical procedures, and they actually delivered impressive results over there. So to operate safely, a surgeon needs to be able to react to physical and visual stimuli in under 10 milliseconds. So imagine using 4G for this connection. Your latency itself will increase more than 10 milliseconds. It's probably 30 to 40 milliseconds. So it's definitely not possible. So all this latency in 4G was traditionally required to compress and decompress video content, and then this tactical feedback over cloud streaming vastly. All of this takes a lot of time. Making remote surgery was really unreliable back then. But now through 5G, we are able to achieve 1 millisecond of latency. That's really good. That's like the most like the least amount of latency possible as of now. So surgeons can use the specialized haptic feedback gloves developed by Ericsson to operate a patient via robotic intermediate. So potentially from 1,000 miles away. So that's possible. That's what I meant by remote procedures. So the gloves are able to give the surgeon the same sense as touch as if they were standing over the patient. So while a video from the operating theater is streamed directly to them in real time. And this latency is at 1 millisecond. As I mentioned, 1 millisecond is really low. Right? So imagine playing games with one millisecond latency, right? So that's possible with 5G. Let's hope that Geo also brings 5G to us fast. Anyway, so next we have remote monitoring. So the large connection of 5G makes it possible to connect a large number of medical sensor terminals like IoT devices. So maybe video devices or wearable biomedical devices like something like a pacemaker to achieve real-time perception and measurements and capture and transfer patient health and to realize a continuous and accurate monitoring of health information. So various medical sensors and wearable biomedical devices can collect real-time patient data, including body temperature, heart rate, blood pressure, blood glucose, and all. And these devices can be connected to the cloud, and then the AI, artificial intelligence, can be used for the analysis of the patient's health-related data, and then record all of this data. And even the doctors can have access to all of this. And what if just a simple issue over there? The users, like the patients, can get alerted on their phone also, and all of these can be monitored real time because 5G has this new bandwidth over there, and there's a lot of space available for devices, so they can all be connected simultaneously, like at the same time. You don't have to worry about you go first, not. They can all be connected at the same time, share the bandwidth, a considerable amount of bandwidth. So the doctor can also evaluate the patient's feedback wirelessly and all. So you need not have to go to the hospital and stuff. So next we have 5G in manufacturing. So what do you guys think about the manufacturing industry? Why do you think manufacturing industry would be 5G? Anybody? Yes, to improve productivity, yes. So let's see the like 5 points. Let's take like 4 points over here. There's something called process automation. Automation is what every manufacturing industry is going through right now. So 5G is one of the key enablers to the smart factories. So as it gives like the manufacturer's ability to create highly reliable systems that can sustain the web of information passing through various machines and devices. So automation in factories will get a major upgrade with introduction of 5G. That's for sure. So next we have like collaborative robotics. Okay, so manufacturers employ like a variety of robotics for like robots in the factory, right, for the industrial tasks. So these robots that can like there are robots that can move products from one place to another, or they're designed to work alongside humans to check the work or something like that. So most of these industrial robots are connected using a wired system, and the data required to power a warehouse of robots cannot be supported by the current wireless speeds. I mean, 4G was not able to process all the data in a fast manner. So that would decrease the efficiency of the whole manufacturing process. But 5G, since it has this whole high, like the really high data speed, and then it also has a really low latency, now it's possible to do all of this wirelessly. And you can even actually run a whole factory from sitting at home. You don't even need to have people over there. You can monitor everything, just like the remote monitoring I said in the health sector that can be used in the manufacturing sector as well. So with this, the robotics industry is also expected to see a huge growth in the next few years. Okay, how will 5G change the? Oh, currently 5G. Okay, okay. So it's not like a wireline architecture as of now. In the industries, what I'm saying is right now, since 4G speeds were not as capable as 5G, there's a lot of latency over there. Latency was the main issue. Yeah, yeah. So latency was the main issue. That's why we weren't using 5G, just using wired connections for robots. Now we are able to use like the wireless networks due to 5G. That's all. So how fast will 5G adapt and work with other technologies like IoT? Well, it's still in how to say developing countries like India. It will take a lot of time right now. We're still experimenting 5G. But in US and all, they already started integrating with the health sector and remote surgeries that I mentioned before. They already started happening. So 5G is pretty quick right now, and this research for the next what's next to 5G also just started. So that's how fast it is. And obviously, yeah, there's going to be a considerable amount of investment to get all the equipment ready for 5G. But that's something that everybody will take. So next we have remote monitoring of production assets. So as I said before, like that's another benefit for the smart factories, right? So operators need not be in the same floor, or they can just be anywhere else, and they can still keep track of all the operations real time through softwares. So they can also gain like insights into their device performance. So there is algorithms, machine learning algorithms that can predict when your device is gonna fail, or what's the like what to say productivity rate or something like that. So all that is possible with this now. So next one, you have the new business models. I mean, 5G is going to change the whole industry. So emergence of 5G opens up new business models in the manufacturing segment, like ability to control various devices through mobile networks allows operators to stretch the creativity to its limit. I mean, You guys must have seen this video on Instagram and Facebook and all where drones were being used as like delivery drones. Amazon was talking about it. So you can start expecting more of these drones, and they can also probably implement it in India too. Right? So drones, yeah, exactly. Prime Air, yeah. So they can start right now. That'll be 5G is going to be really useful for them. So drones require a lot of data transfer, like in like data networks, require on to fly great distances. So, however, in the air, like current LTE networks are prone to interference, right? That's why it's difficult to use like monitor them because of a lot of these interferences. It's difficult for us to monitor using 4G LTE. Otherwise, it's normally possible to even use 4G for the drones. That's why they're just limited right now. But 5G will give 5G is a solution to all of those limitations. So even drones can be used inside factories also. Right. So you guys have any other points to add in this? You guys have any other thoughts in the manufacturing sector or any other sector for that matter? I just included health and manufacturing. What about you guys? You guys must have a lot of other ideas too, right? Okay, no questions, I guess. That's fine. So next, let's see a bit of a fun part. In, oh yeah, 5G in gaming. Yeah, definitely. As I already said, 1 millisecond latency for your games. Imagine that. That's all I want to say. That's going to be a totally different experience. Anyway, so next, let's see a few myths about 5G. There are a lot of people saying a lot of stuff over here. Let's discuss a few of them. First one, the most common one is 5G is dangerous. I mean, there's no definite answer to this. I mean, research is still going on the effects of 5G. And the WHO has declared that as of now, there are no life-threatening effects from 5G. And that's like as of now, it's not. They haven't discovered anything. Obviously, there's gonna be a bit of an issue with the radiation. I mean, that's true for any signals. That's even true for our Wi-Fi over here, right? It's different for it's same for your mobile phones also. We're still using that, right? So 5G is no different. There's obviously going to be a bit of effects, but it's probably in the long time, and we are not able to discover them right now. So, but this debate will like go on forever, and in the meantime, all the network providers are going to give 5G. Like they're going to implement it commercially everywhere, and that's what's going to happen. So myth number two, as we already seen, it's like it's not going to impact just the telecoms industry. A lot of people think 5G is just for the telecoms. 4G is fast enough. Why do we need 5G? There's a lot of health issues. That's just not about it. That's not it. It's not just about telecoms industry. There are a lot of other industries with that. So maybe entertainment or even farming industry, for example, 5G could be used like for near instant communication between different farming apparatus. So this will allow one operator to remote operate various things from tractors to combine harvesters and much more. That's going to be pretty useful. Yeah. Next one, 5G will replace 4G completely. So that's not going to happen as of now. I mean, so right now, you remember how long it took for us in India to get 4G, while when we were just about to get 4G, other countries were actually testing 5G already. So that's how fast it has been, and it's going to be a gradual change, you can say. Like dominance of new wireless network from history, you can actually see it's more of an evolution than it happens overnight. So no wireless network has wholly replaced its predecessor. So India like still has places with where only 2G and 3G networks are available. So there was a question before, right? Why has it been changed to edge, right? Yeah. So that's the point. So it's like not everybody's having the device. Maybe the device is not supported, or maybe there's no cell tower over there. So there's always this backward compatibility expected for all customers. So they can't completely remove a whole network. Oh yeah, yeah, Ben. If people switch over to 5G, it is cool. Yeah, definitely. But you gotta wait. So myth number four, 5G spreads COVID-19. I know it sounds extreme, but this specific myth gained a lot of noticeable traction in the early days of the pandemic. I mean, however, this could perhaps largely be attributed like the pandemic panic, not so much to 5G, but still the ongoing debate regarding the safety of this electromagnetic radiation associated for 5G. That is for sure. That's probably there, but it's definitely not the spread of COVID-19. I hope nobody over here thinks that it spreads COVID-19. Okay. So next, bringing 5G in India. I mean, 5G bringing a 5G network in India is an ultimate challenge for network providers. So like countries like China and USA had already started the testing process like 5G. We were glad for the introduction of 4G, as I already said before. So now we can take out how much time would it take for us to launch a 5G network service in India. Just yesterday, I saw that Airtel was starting trials in some city actually. They're just gonna start, and even that we are not so sure because as one of you mentioned here, right? They were advertising it as 5G, although it's just 4G LTE. Right? So in some cities, the speed of 4G LTE is slow, and working on the speed like doesn't make people enthusiastic. So it means in some part of India, it's still not able to use 4G technology properly. So moreover, not a lot of 5G compatible devices are also in the market. So right now they just started coming out, and not all of them are going to upgrade right away, right? I mean, 4G is nice, it's stable, and we're all using it together. So that's nice. That's what you're going to look for right now. But in the meanwhile, like maybe in from 5 to 6 years, everybody would have switched to a 5G phone at least, maybe 20%. So in the future years, we'll see a lot of increase for that. Yeah, if we take 3G and 4G, yeah, exactly. 3G and 4G took a lot of time to implement. Yeah, okay. So what next after 5G? I mean, there is no such thing as 6G as of now. But if it does come out, experts believe that it will achieve speeds of 1 TB per second. That's probably too much for anybody, but who knows how much data will be transmitting at that time. So what if 5G also becomes just like 4G, and then all the whole like the 6 to 300 gigahertz bandwidth has been filled. Yeah, and bandwidth has been filled, and then you have to increase the spectrum even more, so that you need to accommodate more devices. So at that point, that is when 6G is going to be introduced, if there is one. So and they're also expected to use terahertz waves. So obviously, this technology is going to be like great help in every industry. It will have a huge impact on society. Oh yeah, Shakti. Yeah, yes, cloud security is going to be improved as well, definitely. Yeah, so that's about it, guys. Thanks for attending the session. That's all I have to share over here. You guys have anything else to discuss? I'm open for you over here. You can use the chat or you can unmute yourself too. Oh wow, okay, that is kind of a burn, but okay, okay. 1G has a range of 2 to 14 kbps. VIT has 1G. I can't really commit on the speed of VIT right now in VIT Wi-Fi, but yeah, it is really slow because of there are a lot of people using it simultaneously, right? As I said before, if the frequent oh yeah, 4 to 5 Mbps, yeah, exactly. Yeah, labs, yeah, the labs are pretty fast. That's where we do all our FFCs. Yeah, Anshuman, you can stop the recording.